So in any case, whatever happens, this is always true. That's why this truth table proves this statement. This is a proof of this compound statement. Similarly, you can prove this one. Let's just quickly modify this table to prove the second one, which involves conjunction in place of disjunction. Okay. Now here what happens? X, before, X is either true or false. Now if X is true, conjunction is true if both the statements are true. Now in this case, since both the statements are the same statement, so X is true if X and X are true, and that is the case, so this is true. And conjunction is false if at least one of them is false. Now in this case, both the statements are the same, so if X is false, then both of them are false, so this is false. So in this case also we see that either these two are true together or these two are false together. So that's why this double implication is true, or that we have equivalence. So we have proved this one also. So we have proved idempotence. So like that, we can, of course I am not going to prove all of them, only some of the more difficult ones. I will, okay, let me now prove. I am not going to prove commutativity. Okay, rather what I do is that I will write down the truth table, not in its entirety. I will leave it unfinished. Okay, so you may go through it and complete it. So now I am going to prove this equivalence. One of the commutative laws involving disjunction. So here the truth table, now note that unlike the previous one, here we have two statements which are not necessarily the same, X and Y. They may or may not be the same. So we need two separate columns for them. Okay. Now here we have one column for X, one column for Y, one column for X or Y, one column for Y or X, and one column for the double implication. Now in this case, there are four possibilities. Why? Because each of these two statements can take two truth values. So X can be true. At the same time, Y can either be true or false. Or X can be false, and at the same time Y can be true or false. Okay, so these are four possibilities. So these are the four possibilities. Now let's look at these disjunctions. When is a disjunction true? When at least one of X or Y is true. That is, either X is true or Y is true or both are true. In this case, both are true. So that means this is true. In this case, in these two cases, at least one of them is true. In this case, X is true. In this case, Y is true. So disjunction is true. However, in the last case, both of them are false, and that is when disjunction fails to be true. It is false. And I leave the rest to you. You will see that this will always be true. So we have equivalence, and we have proved one of the commutative laws. One can similarly prove that conjunction one, and similarly one can prove the associative laws. Now let's come to the somewhat difficult to see why it is true, the distributive laws. One of them I am going to prove. Let me prove this one. X or Y